Okay, so we've gone mostly over what we've gone into class, except for with the chops part, which is what we're about to get into. And I am hoping that this will, that this is something that we can refer back to. And that I hope that it helps to clarify some of the information that we went over in class, because I know that that's kind of a lot of information and stuff. So I'm actually going to switch this text port now into a motion FX view. Right, so that automatically pops us into the chops context, chops, right? But object, we want to be in the object node. It's a little confusing at first, and we haven't talked about it too much, and I don't want to get too far into it, but we've definitely talked about all these contexts. And this is the standard place where these contexts exist. So we have the chops, we've talked about this, the image, the compositing, the materials, the object, and the out, and the pretty much depreciated chops, the old material editing interface. So we have the chops, but we don't necessarily have to use that chop network. We can basically make our own managers, and so we can just come up into here and type chop. And you can see that we can create a chop network inside of our container. And it's the same exact thing, literally, is going over to here. But it gives us the added ability of keeping it under one container, so that if we wanted to put it into a tool, those Houdini digital assets, we could keep all of our paths contained and in one place. So we could just dive down in there, and now we're basically in the same place that we would be with all the same tools in chops in this context, but we're down, buried into our asset here. And that's pretty cool. So I'm just going to kind of slide this open, and I'm going to hit the tab key, and last time we created a pulse. Right, so a pulse is just going to make pulses along a period of time, which is going to be specified in the comments section. Usually I'm going to put that to frames. And what we can do is set our end to 300 here. So now we are back basically to the same. And you can also cycle these so that they'll go on forever. You can hold them, slope them. There's a bunch of different options. For this particular case, we're going to put in cycle. Come over here to our pulse. Next thing we're going to do is we're going to add in a map. We're going to connect those into each other. Okay, so we've got our pulse into our math. I'm going to kind of expand this view a little bit up here so we can kind of just look at the chop. And for now, actually what I'm going to do is I'm going to select that pulse, and I'm going to just turn off the cycling so we can just kind of concentrate on the area of time that we're in, right? So generally, chops are going to create values from 0 to 1. Which sometimes we want to change that. So for that, we use the math. And you can just come into the range, and basically what we want to do is we want to remap the from range from 0 to 1 to whatever we want. So in this particular case, let's say 0 and 10. Okay. So now we have new values, and we're seeing both of them because they're both blue. But we can just have one blue and visualize it. Okay. And the cool thing about the math chop too is that it'll take numbers of inputs. So we could add in a noise. And noise is just exactly what you think it is. It's just noise. It's just wavelength noise. And I just want to turn that off so we can look at the noise for a second. I'm going to zoom into it. And with noise, you can adjust its period. You can adjust its amplitude so that you get values beyond 1, no problem with noise. You can get values beyond 1 with a pulse as well. But oftentimes you'll want to keep those values within 0 to 1 for a variety of reasons and remap them later. It's much, much better to do that. But you can, as you can see, you can raise that above 1 here. We're going to keep it at 1. You can control the roughness. You can control the kind of noise that it is. There's different noise frequencies. There's kind of a cool one you can see is only absolute values there. Random, and I'm not sure, but if you guys know the difference between noise and random, is that random is random, and generally we don't use random so much for things, especially not for animating. Maybe you'll use random to shift something around, but not as usually something that drives something. Random has like no beauty to it or real repetitivity to it. You'll use random maybe to color a bunch of points a different color or something like that, but generally not for movement and animation. Generally we'll use noise, which tends to be prettier and still offer the same results, but with a little bit more art directability to it, right? So that's alligator noise. Brownian, very common noise. You see it a lot in rendering too. Harmonic summation, which I'm not even sure what that is, Hermite, and sparse. We'll stick to sparse for right now. And so, like I said, you can control the period of it, the harmonics, which is just kind of like the density of the curve, right? For the 3D thing, you could think of it, I think, what do they call it in, it's like the number of steps that your 3D noise can take as a shader. And then your sample rate's at 30 because we're at 30 frames a second. If you're working at 24 frames a second, you want to change that there, right? And it's outputting channel 1. This is outputting channel 1. And we can take those, and now we have 2 channels, but we could also combine those. So we can go to combine chops, and you could do like multiply, and you can see now, if you turn the blue off there and just turn the blue on here and hit H, we get this kind of combination of pulses that are made out of this noise. And you can combine things in different ways, divide, average. So that's kind of giving you noises in between pulses. That's pretty cool, right? Maybe that's the one that we'll stick with. Minimum, right? That's actually giving you some kind of cool shapes too. So it's a really easy way of kind of bringing in this concept of this beat-driven stuff through chops, and also having the ability to add a little bit of noise on top of it, because you don't ever really want things to be perfectly static, you know, so you could just add in a little bit and you could lower it down. And then if you wanted to, you could even start filtering some of this stuff a little bit, right? So we could put a filter on to kind of smooth things out. And it's obviously way too much, right? Something like that, maybe, right? And basically, it's just applying a kind of like a Gaussian blur to it to smooth things out a little bit. And then, just like everything else, we're just going to add our null here at the end, right? And we're just going to call this, we can just call it pulse out. And just like always too, I like to color the ends of those nodes black. And now what we could do is, and also I'll usually rename this to chops just to make it simpler on my life. I did it all capital though. So there, oops, there. Now, just like what we did in class, we're going to use that information, right, to come over here and drive this exploded view, right? So just like in class, over in the scale parameter, we're going to use that expression chop. We're going to bring up that parenthetical, and we need the path to our node, and we can type in chop, and then we see the 1, right? So there it is. And then because it's capitalized, that comes out. So we just put down here, and then we just know we want channel 1. And we end it. Oh, forgot the close that out. So now, this exploded view is just being driven by our pulse. Boom. So you can see how we can just easily come and start animating things on a regular rhythm and a regular beat or whatever it is, depending upon what it is that we want to do, and that we have a lot of control over how we want that to look down in here, and we can use this curve for us in order to be able to see what it is that we're doing, right? So we can even come in here and so you want to add 10 to that, and then we get this crazy thing again here that's going to be a lot bigger. And if you come up, you can see that it's more exaggerated now, right? So we're able to animate these things. And eventually, even if we wanted to, we could actually kind of like animate shifts, so things animate kind of separately but on beat at the same time so that they're not all grouped together. There's ways of shifting these chops around, very similar to how we're able to copy different objects and that kind of stuff. And so this becomes the root of a very powerful way of procedurally animating objects in a controllable way, especially if you want to do beat-driven stuff for music, because you can really get it down where if you know what the tempo of your song is, or the BPM, right? This is something that we commonly call it beats per minute. And oftentimes in this present day and age, a lot of things fluctuate between 120 and 128. Then we can use like these pulses, or we also have this thing called a trigger. So we can look at that too, right? So I could pull off that pulse, and I could look at the trigger now and pull that so that I'm not looking at that or that. H, right? Trigger is kind of like a pulse. It'll take the pulse in, but looks what it gives us now. So it gives us, instead of this kind of sharp, spiky curve, it's giving us this nice slope shape. And we can begin to come in there, and we can start figuring out how we can actually get a much, much nicer kind of thing. We can control the attack length, and usually we'll have it something like that, offset, right? You can make it sustain at the top so that it'll hold and then come back, right? You can control how you want the shape and ease in or ease out. You can come to the sustain and say how long do you want it to be released, and you can begin to start changing that. And then if you wanted to, you could just add in a switch here, just like you can in the other context. So I'm going to pull that trigger off here. We'll pull that into switch 1, so let's pull that over to there, right? And so now let's come and look at our pulse out, turn that one off, right? And let's switch this. And now you see we get this other kind of more smooth shape, these kind of gradual types of animations. I'm going to put the monitor dark here for that. Right? So I think that pretty much covers what we went over in class for the most part. I hope you find this guys helpful and helps to kind of encapsulate some of that information. You know, feel free to always email me. Don't get stuck, because there's no reason to. And other than that, I'm going to upload this file. I thought just as a little bit of an extra that what we could do is we could look at what we kind of went over in chops a little bit last week in class and look at how it kind of relates itself to Touchdesigner. This is what you see when you first open up Touchdesigner, and that this is selected. So we're just going to shift and hold down everything and delete all of that out of there. We went over the Touchdesigner interface a little tiny bit on the first day, but we can look at it a little bit right now. Obviously it's somewhat similar to Houdini, but it's also a little bit different in that you kind of work in the viewport. But other than that, you hit the tab key, and that pretty much pulls up all of your different contexts that you have. Some of these should be similar to, familiar to you, chops and sobs at least. In Touchdesigner, unlike Houdini, you don't really have the object context. You kind of have root, and then you lay down your containers. And it's very, very common to start your first Touchdesigner project, or the root of your project, with just something called a container, right? And you could just call that container my project. And then you could dive into there, and we're inside there. And I did that by double clicking on it to go inside of there, similar to Houdini. You can also hit the Enter key, and you can also click up here, top and bottom, like that, right? So we're just going to dive down in there. And very similar to usually get started, just like in Houdini, you're going to lay down a geometry container, so geometry. And that is just pretty much just like Houdini. And in Touchdesigner, I'm going to just zoom out here a little bit. This is a torus. It's automatically created, and truthfully, we're going to delete that because we're not going to use it. And so now we're in SOPs, just like in Houdini. And a lot of the tools are named the same, box, etc. And you'll see that as we progress, even more of them are named the same than you think, because there's a lot that we haven't looked at yet that we're going to look at in Houdini, especially things like the carve, which we haven't gone over yet, which is carve, which is a super cool one, which we'll be looking at next week. And but other than that, we can make a box, right? And we can make a sphere, just like we can in Houdini, right? And also, we can make a switch, just like we can in Houdini, right? So we should be pretty familiar with all of these concepts, right? And we can also make a null. Nothing surprising here. In Touchdesigner, you don't actually need to capitalize it. It's a little bit different. You can or not if you want. And we can dial that into the end of the chain. And then it's a little bit different, but what you need to do at the end of your chain in Touchdesigner is you want to set that one blue for display, and then you want to set this one purple for render, right? So that way it becomes a renderable object. And you could also turn these off so that we don't have to even look at them, being drawn in the viewport. Anytime anything is being drawn in the viewport, I just clicked this arrow and that turns it into an actual 3D window. This is a 3D window. It is being drawn. So anytime this is being rendered, it is taking up memory in your GPU. I mean, obviously not very much, but it is being taken up memory in the GPU. So usually you'll kind of shut those off unless you need them on. Right now we'll leave this one on up here, right? So we have this geo container. So in order to render in Touch, you need to have a render top, and you need to have a camera. And that's going to be under here under comp, camera. And you'll need to have a light. So now we can click this blue thing and we can see our render. So if I was to like come over here and I was to rotate this in 45 degrees and 45 degrees, we can actually just do on all axes so we get this cube, right? And we can also just come over here to materials and we can just make a material. So in this particular case, what we'll do is we'll lay down a PBR, right? Even though we don't have any we're not going to apply any textures to this, but what we will need to do is to come over here, enter. So where do they have their environment? They have a new, I might be not in the new one, so we would have to lay down an environment light. Yeah, I mean, this is, I'm not using the experimental version of Touch. The new experimental version has a pretty cool automatic environment light feature. So in this particular case, I'm just going to make a constant that's white and drag it into the environment map section. So I'm basically lighting the scene with just 100% white light. This is an environment light. What I did here is, you see, I just drag it on top. And then I just said, oh, I want that color to go into the environment section. So we connect things in Touch like that a lot. Same thing with the texture. You just drag it on top, par material, and you'll see that it'll show up in render, you can see material. I could delete that. We could do it again. So this now has no material. I just drag it on top, part material. Now it's on there, right? And that's pretty much that, right? So we've got a piece of geo, you've got this here, and you've got a camera, etc. And so just like in Houdini, you could come down here and you could start using your transforms to move something around by taking a top and a transform. And we could just wire that in and wire that in there. And we could move this around. So if I was to come up here, I could do that, right? That's a vertex cache. And that's fine for moving it down in there, but you definitely don't want to animate down there, right? So I'm going to set that back down to 0. And if you middle click over on, it's just like in Houdini, if you middle click over, you get information about your rendering. And in this particular case, you can see though that we're rendering at 1280 by 720 at 8-bit render, and it's taking up 78 megs of texture memory. Not a whole lot, right? And so an altogether 72.36. And we have quite a bit left, so we're using up a total of 200, and we've got 16,000, so we've got some room to go. Anyways, so what we can do in Touch is we could do something like this. So we could take in the SOPs, not in a geometry container, because that's not what we're going to use it for, is we could create a grid. Right, so take a grid. We've created a 3-dimensional grid with 20 rows by 20 columns, right? And I can look in here and rotate and see the grid. And with it hovered over, I could hit the P. It's a little it's confusing, but it'll bring this up, and I could actually see the points on there if I wanted to. And right then, just as a simple construct, I'm going to move this over. So I see like that. I'm going to add in a noise just for fun. This is not really the way that you would do it in the final one, but it'll work for this. And so now you can see that we've got this animated noise thing happening, right? And I'm going to create what's called a SOP2, right? SOP2 chop. And you can see it, you lay that down, and what I could do is I could just drag it on over that. And now you can see what we get is we're getting channel data, chops, channel data, just like we were seeing in chops in Houdini, but right now, instead of generating it through just pure channel data, we're getting it from geometry, and we're defining those positions. These are the positions in space, right, of these points moving through time. And you always also, you want to always, just like we always do, I can't stress it enough, you add that null at the end in case you ever want to do anything to it. And we'll just call this, we're going to call it INST out. Okay. So now we've got this kind of 3-dimensional array of positional data that's coming off of this noisy grid, and the noise is animating because just like how I showed you, we could animate the noise with that offset Z parameter. And it's the same exact thing in Touch. So just over in the transform Z, you can see there's something animating. It's moving through space. And in TouchDesigner, it's an expression. It's a very simple one. ABS time, capital is called camel case, dot seconds. And we can do the same thing that we've seen that we can do in other things. I could slow it down just by multiplying it by 1. By 0.1 rather, not obviously by 1. Boom. So now we've got this slow, noisy grid thing happening. I'm just going to hit save and save this real quick to the desktop. And there we go. So now I've got these points, and they're even named TX, TY, TZ, right? And I think that what I'll do is you can right-click, and I'm going to insert an operator over here, and I'm going to add it for when I know we need it. It's going to be called a merge, right? So, and I can add in other channels now, to that, right? So I can just I could do all kinds of things to get other channel data into there. We'll see a little tiny bit of that. So now we've got this thing INST out. We know we've got this, our geometry here, our square. It's pretty big, so truthfully I'm going to dive down into there, and I'm going to make it in size. Instead of being 1 meter, I'm going to make it 0.05, 0.05, 0.05. So now we kind of have this much, much smaller white cube that's just kind of like floating there in space, right? So what I'm going to do now, I've got this container selected. This is our cube. We could call it cube. Lowercase, or it doesn't really matter. And I'm going to come up here to its container. It's P, just like it is in Houdini. And I'm going to look at this tab, Instance. And its instancing currently is off, but I'm going to click that on. And you can see now that this interface is opened up over here. The cube has gone away. And I'm going to drag this to here. And that now opens up these parameters. And at least there's one cube there. But what we can do over here is we could say TX, TY, TZ. And now what we've done is we have instanced our cube onto that thing. As many points that exist in this grid, as large as this grid is, so we could raise up the size of this grid. Right? Pretty cool, right? Now, what we can do is we could, let's do this. Let's add in a top. And what we want here is we're going to call it, we're going to get our noise top, right? And this grid is 20 by 20, so we're going to set our noise in the common size to 20 by 20. And in this particular case, I'm going to put it on nearest pixel just because that's what I want. And over in this noise, I am going to set it. It's on simplex. There's a bunch of different kinds of noises in Houdini, but don't ever use the ones that don't have the GPU mark. So these are the ones that you can use per lin. There's not that much difference between them, in all honesty. Random. Simplex is pretty much one of the fastest noises, so I would kind of stick with that, right? And we want to take it off monochrome so we get some color noise. So we can see, and you can see that we're zooming way into it now. And the reason that it looks all blocky like that is because I did take it off of interpolate pixels. So right now we're not doing any interpolation, any aliasing to kind of blend them together. And that's because we don't want to, right? So now, middle mouse clicking over it, you can see we have this thing and it's got 4 channels in it, RGBA. So what we're going to do here is we're going to use a top 2. Just like that, SOP 2, top 2, right? Pretty simple. And I am going to just drag that onto there. And now we've done the same thing that we did up here, but we've done it with RGB data, right? Instead of positional data, right? So now we've got these new channels, not TX, TY, TZ, but we've got these new channels RGB, and I can just come off of here and put those into the merge, and now they're available, right? It looks like we need a lot more points actually there, so I think that we're going to have to take this and just keep it at 256 now. I think I would have, you have to keep it at the number of points are equal to we even need more. So we need like, I don't feel like busting out the calculator right now. So let's just put it to 512. It's probably a little going to be too much, but that'll be okay. So now we have these two, actually it looks like 512 is good. Now a little too many. You can see because the color information is going beyond that right there. So, but really it's not going to matter because all that I really want to do is come down to this geo container, and you can see there's nothing for color, but if I come over to instance 2, there it is. And I can just say, all right, let's just set that to R, G, and B, and now we're driving the color of these individual boxes based off the color of these, right? And even if we wanted to, we could come over here and be a thief and just grab that, steal it, right? Why not? I like stealing things like that. Come on over to the transform here, paste that in there, and now we're going to be able to get these cubes animating with different colors and different noise. Maybe we want to speed the noise up a little bit, right? We could even make that our own expression eventually so that we would have a slider that could control that noise, which is something that we'll be definitely looking at, right? So now the last thing that we'll do a few more things, right? So again, like let's just shut that off. Well, we don't want to shut those ones off, but just those ones for now. The other thing that I want to do is, because right now we're basically looking at our render top in the window, right? So by turning that blue, I can look at it on and off. And that's fine, but it's not like the best. So what we really want to do is, like always, we bring up a null, our null top, right? And this is going to be called, I think Jarrett would always say call it underscore out. And we're going to drag that to that. Instead, now we're going to make that blue. We're playing both windows at the same time. You can play as many as you want, or your graphics card will allow. We're going to add in a constant. Set it to black, 0, 0, 0. And now I'm going to come over here again, and I'm going to right-click, insert operator, and I'm going to add in an over. And I'm going to, it's already connected to the top, and I'm going to connect the bottom in. It looks funny because we have to change something over in the over, and because it's set to the fixed layer of being layer 2, I just want layer 1. Boom. Now we're back. So now we're only rendering at the end of our chain. Remember, it's running all of these things, so we turn them off. Right? And let's get back to looking at our channel data. Right, so now we have got this, and that's for our RGB, but let's say we wanted to have another one. So let's just turn this on for a second, and I'm just going to copy and paste it, right? And I'm just going to translate it a little bit so that it's different noise, so that they're not tiling noises, right? And then I'm going to do the same thing here. I'm just going to copy and paste that. And I'm going to, you could just come up here to this noise and just change the number there. Make that a 3. So now these are connected. You can turn that off now because we don't need it. And we've got these same channels, R, G, and B, right? And so I need to call this SX, SY, SZ. Oops, I didn't mean to capitalize that. Sorry about that. SY, SZ, and we're just good. I mean, we can keep alpha. We don't actually need. I'm just going to actually delete alpha. Now we've got this group of channels now that are running from 0 to 1, and they're alternating, and they're named SX, XY, SZ, and we're going to add in a math chop, just very much like what we did in Houdini, and I'm going to pipe that in. And now I'm going to come to the range, and I'm going to remap those values from, instead of from just 0 to 1, I'm going to make them from 0.1 to 4. Okay. And now what I can do is I can just pipe that right on into that merge. Now those channels are available there, right? So you can see that they're available there. And I'm going to come back to my cube here, right? And I come to the first page, and I'm going to just grab those ones right there. SX. You could type them too. SY. SE. And now we're getting these changing scale patterns that are all animating over time. Changing the colors, moving through the things. We can come up here. We could look at the camera. We can change the FOV. If you turn on, it's hard to see because it's not going to render the full image with the lighting and the camera view. So you can hold down the P key to bring up this dialog. It takes this P away and brings up this P and then put on the points. And it's not even doing a great job of letting you see what it is. The camera, the moving the cameras around in Touch are, it's not as intuitive as it is in other 3D applications. Very rare that you would even do it in the window like I'm doing it. You do have a network view, so I could split my windows here. So I did that by just clicking up here. So single window, double window. And I could change this to geometry viewer. And we can see we get this kind of approximated 3D view, right? So I could say something like, just knowing that looking at the view makes it a little bit easier. And let's take this grid. I'm going to hit the P key up here, and I'm going to put it on the YZ plane. And if I wanted to, I could insert a transform. Insert operator. Or sorry, insert operator, SOPs, transform. You rotate it 32 degrees or whatever you wanted. So anyways, so you can see how both Houdini and Touchdesigner share this kind of common way of using this CHOPS data, and in CHOPS you have a lot of the same information that you would have in Houdini. There's some different ones that do some different things that Houdini doesn't have, but by and large, especially when it comes to the kind of channel data that you see in Houdini, there is always the equivalent in Houdini, in Touchdesigner for that. It's additional. The one thing that's super cool about some of the, depending upon, I just added a lag. That's not what I wanted. I wanted an LFO. Some of the cool things that are different about the ones that are in Houdini is that in Houdini you kind of have to figure out and set your time, you know, right? So you have to use that common parameter and make sure that you're always in sync. But you can see down here in Houdini you have tempo, right? So right now we're functioning at 120 BPM. And so that when I create certain kinds of chops like an LFO or a pulse, or something along those kinds of lines, they're going to be timed correctly and functioning at the correct beat. So you could pass that information through to certain things. Like let's say if I wanted to, for some reason, I could create a ramp here in the top section. So we're going to create a 2D ramp, right? And I can click this window. So once you click this square, it makes grabbing that information in that channel 1 there possible. And so like I could, with this ramp selected, I could grab that channel 1 and set that to like the period. And just like we do in Houdini, say, relative chop reference. And you can see now that that ramp is animating. And potentially, let's say we could put this into the, let's put it into the base color map, I guess, right? We could come back into this ramp and we could take this black, and now we're just multiplying on top of the instance color, you know? right? So this is acting kind of as a multiplier for the color that's coming off of what we have on top of there, or an add, rather, probably. But soon it'll just take over. Unless we come back here and let's make that one white. So now you'll see where the color from the points, wherever I have it white, the color from the points should come through pretty clear. Right? We could even change this if we wanted to a radial ramp. Because these, or a circular ramp. Right? So we can get kind of all these kind of effects that are all timed to the beat, that we're controlling the positional information through this channel data that we're getting, that's getting passed down through. And it's very similar to this. We could create this in Houdini also, but we talked about these point attributes. So these are just these float values. Anyways, I think that's about it for this stuff, and I will see you guys on Monday, and have a great week. That's it.